want to head over to Neuron next. And James, we need to stick into 25 minutes, up to half an hour, okay? Help me out. For anybody who might not be familiar with James, could you give us a quick introduction about yourself?
Of course. Thanks ever so much, Tudor. Tudor's doing an awesome job, by the way, for this community. So, big shout out to Tudor and the rest of the Headstarter team. But yeah, I'm James. I'm our CEO and co-founder. And really what we're doing is providing a gateway into like DePIN and AI resources. We're living in a world at the moment where AI, if we looked 5 years ago and you said to people that you'd have an interface on your PC where you can ask it basically any question, ask it to code anything, ask it to generate images or videos, and it would pop out, 10 seconds later with the answer, people wouldn't believe you. But we're now moving into a world now where AI, machines, data, agents and AI models are all being sort of integrated to deliver some sort of substantial applications. What does Neuron do within that ecosystem? Well, a lot of these different resources that plug into customer applications, there's two ways that we can connect all of these different systems together. One of which is through cloud applications. The other of which is directly, let's integrate these things on the edge and so they can directly communicate with each other. Now, if you go through clouds, you basically end up adding latency to all of your communications. You add cost because these cloud systems are quite expensive. And you also end up adding potential points of failure, single points of failure to the system. So, you could end up losing a whole network of data sources or a network of robots or a network of agents, just for a server going down, which is obviously a bit problematic. So what we do is we enable machine-to-machine communication and value transfer between any two machines in the world. And when we talk about machines, what we're talking about really is anything with a computer chip in it. We can connect these things directly to one another and transfer value between them. And that's across any network. And where does the Neuron bit come in? So we have an SDK which connects the machines together, but we then have a validator network which basically is securing the transactions between those machines. So we're portraying ourselves as this huge validator network which is really securing the machine and AI economies. And that's really in a nutshell, I guess, what we do. Where have we applied this? So our first use case has been in drone and aircraft tracking, which has become a very hot topic in recent weeks with the helicopter crash in the United States. I think it was even Elon Musk was saying, we need a system to be able to track aircraft in 3D, everywhere in the world and connect these things into all of the ATC systems. ATC's broken, air traffic control. It's stuck in the 1960s, really, with people. I'm not even joking when I say this. There are air traffic controllers looking out the window with binoculars in a lot of these small airports. Don't have any digital systems in them. The bigger airports rely on, primary and secondary radar, which costs sort of tens of millions of dollars per unit. So the smaller airports can't afford that. And with the advent of drone technology and air taxis, which are now sort of coming online in Dubai, what we need to do is to fully digitize and upgrade these ATC systems. So coming back to the original narrative of machine-to-machine economy, what do we do? Well, what we're doing is integrating these sensors into drone systems directly. So you've got sensors being one machine and the drone systems being a secondary machine. And we can integrate those at the edge, so that they can avoid things like latency, which is a problem. If you're seeing an aircraft 2 seconds after it's hit you, that's a big problem. You obviously don't want to add huge amounts of cost to this network either, because you want to keep things cheap. Drone deliveries need to be done for, a couple of dollars per delivery. So if you're adding $1 million radar system or huge cloud infrastructures, which are expensive, then you can't hit those price points. And then finally, if you're adding single points of failure to the system, then ultimately you end up all drones going blind for any kind of failure of this system. So it's really important that we decentralize access to these sensors. And that's exactly what Neuron does. We're the first project of its kind globally. There's nothing like it out there in the real world that enables edge communication to flight tracking sensors. It is the only way that we believe is going to work, and be robust, secure, and reliable. And drones is just a starting point. We're now working with an AI agent company who are basically vertically integrating an agent with the flight tracking network so that they can get real-time hazard detection for any potential collisions or any weird behavior that might be going on. And those agents can then be integrated into air traffic control systems to actually alert air traffic controllers to any potential hazards. So if this was in the States, 3 weeks ago, that crash may not have happened. And this is something that's now on the rise in the UK. I've got a little bit of alpha actually, which I can share with you today. We just won a £450,000 project with the UK Civil Aviation Authority. So this is the UK regulator who is now paying us to employ this technology in 3 airports in the UK. Obviously that's a starting point for us. But this is a starting point that is going to grow outwards from there. They don't pay projects if they don't think they're going to be successful. And they see the value in what we're doing in terms of increasing safety, increasing security, and pretty much situational awareness for all airspace users, including drones and air taxis, and all the traditional aviation players. So this has been a huge win for us. We're actually going into the airport next week and going to be installing the software into their air traffic control tower. So you should see some cool videos coming out in the next couple of weeks. But that in a nutshell is where we are, what we're doing. Where are we heading next? Well, drones need lots of different data sources. So flight tracking data is one. They need to know where other aircraft are. But they're also very interested in weather. Quite often there are limitations with these aircraft. They can only fly in certain wind conditions, or maybe if it's hailing or snowing, then maybe some types of drones might not be able to operate, or there might be some constraints with them. So weather is another type of data. So we're going to be working with one of the big weather DePIN providers, WeatherXM, if you're familiar with them, to integrate their data sources. And additionally, they also need access to satellite GNSS navigation systems. Most drones have GPS on board, but those GPS devices only are able to track the drone within about 5 meters of accuracy. Now, obviously, that's fine for some applications, but when you're wanting to do deliveries, maybe someone's back garden might only be 5 meters wide. You don't really want to be dropping off a package into the next door neighbor's garden. So it's really important that these guys are able to get accurate positioning. And the only way you can do that is by using ground-based GNSS networks, which basically correct the GPS signal on board the drone, and provide it with sort of 2 centimeter accuracy. The other benefit of getting that kind of accuracy is you can also attach a camera to your drone and map the ground with incredibly high precision. If anyone's familiar with a technique called photogrammetry, it's basically the idea of 3D modeling the ground using accurate positional data. So, when we look at the drone application, flight tracking is just one of 3 data sources that they need access to. And then we can vertically integrate agents into these different data sources to provide insights, which could be used for a whole range of different applications. Moving into the future, we see things like Tesla's Optimus with the humanoid robots being, something that sounds like a sci-fi movie. It sounds crazy, for me to say that. I'm not generally a big hype person, but I really see that the AI cycle is speeding up innovation at a rate that we've never seen before. AI is building AI, and it's getting to a point now where machines are going to be integrated with AI, where you're going to end up with a robot inside your house basically doing all your chores for you. And I don't see this being that far away. I think we're probably a few years away from seeing this rolling out into people's homes, and probably 10 years away from it being commonplace. So how do we leverage this trend? Well, ultimately, what we don't want is big swarms of robots being controlled in a central way. We want to decentralize this. We want robots and machines to be able to do business with each other and to access data sources in a decentralized manner. And this is really where we sit. We sit in that machine-to-machine economy. So I've probably been speaking for about 7 or 8 minutes, but hopefully that's given you a bit of a background as to who we are, what we're doing, and where we're going.
I love it. Every time I have the pleasure of catching up, listening to James, it's personally amazing because it just opens up my eyes to a lot of the possibilities of the future and what we can do with robust, decentralized DePIN networks. And it's very remarkable the fact that they're able to build such a robust infrastructure on Hedera that government entities are keen to support their endeavor.
There's literally drone and air taxi companies now setting up in Dubai, and so it's a really Dubai is the place to be for drones and air taxis actually, because the regulators over there are very, very amenable to innovators. They want to move quickly, they want to make decisions fast. And ultimately, I think Dubai is going to be probably one of the early cities to enable air taxis. They were already talking about connecting the airport to various different areas of Dubai. So yeah, getting sensors in Dubai would be huge for us.
What I want to touch upon, because it's something that everybody can relate and easily visualize. Since we've had a few tragic events that had to do with air traffic problems and with miscommunication, human errors, how will the implementation of Neuron, the proper use of 4D Sky and the infrastructure that you guys are building, how would it be able to circumvent and prevent some of these horrible situations?
That's a great question. So there's always going to be a human in the loop with these systems. There always has to be. I think if we start removing the human, then we encounter serious problems, and the regulators won't sign off on it either. So there needs to be some level of human interaction. We can talk about levels of autonomy, but this has been an area that's been studied within academia for decades, where you start off with automation and then you start moving towards alerting and providing suggestions to the human operator. And then you start moving towards the automatic decisions, but with the human override. And then you get to fully autonomous but monitored systems. They're the kind of 4 key levels, I would say, that you get. And what we're seeing is a slow increase up those levels. So at the moment, in the past, things have been pretty much just automated, but with humans, maybe some alerting going on. And that's where we're starting off, which is going to be connecting air traffic controllers with a display screen so that everyone can see the same picture of airspace. We want to detect every aircraft that's in the sky, drones, air taxis, general aviation aircraft and commercial airliners and helicopters. They all need to be integrated. All of the data from those systems needs to be integrated. And we do that with the ground-based flight tracking sensors. So we're working with, obviously, Jet Vision, who are probably the world's leading provider of flight tracking sensors. They've been around for 15 years. And they provide very, very secure sensors. So, what's the difference between these sensors and maybe something that like Wingbits would provide? These can be used for safety critical applications. And the reason why is they basically provide very, very high accuracy timing on every data packet that is received. And if you have a network or an array of sensors on the ground, you can use that timing information to basically verify that the aircraft is where it says it is. If you don't have that, this technique is called multilateration, by the way, for those who are interested. If you don't have that, then essentially you could have someone with a Raspberry Pi pretending to be an aircraft, sending out a signal, and the receiver will be like, oh yeah, there's an aircraft there. But it's not actually there. It's a spoofed aircraft, a fake aircraft in the sky. So it's not a very secure system. Now it's totally fine for, hobbyist applications and, watching to see if your grandmother's just landed at the airport so you can go pick her up. But it's not useful if we're talking about safety critical applications with autonomous drones flying. So how are we actually going to present this to the operator, this data to the operator? Well, first we integrate the data sources into a display for them. That's the starting point. The next point is providing alerting systems. So, like I said, the levels of autonomy, the next step is saying, okay, well, this alerting system could be using an agent, for example, an AI agent that's basically looking at the data, and then looking through that data for potential hazards, and then alerting the operator saying, look, there's a problem here. Take a look at it. And then the air traffic controller can then make a decision about it. But as we move into the future, those systems will become more and more automated to the point where the human operator then just has to cancel it if they don't agree with the decisions, and even just monitoring to make sure that the system is behaving as it should do. So that's how we're integrating these. But this is going into the airport next week. It's starting off basic. We're then going to be integrating alerting systems. We're then going to be adding more and more autonomy as we move forwards. And whilst these are only 3 smaller airports, they're not, major airports like Dubai or Heathrow. They're a starting point for us to start rolling out this network globally on a large scale, because there's a lot more smaller airports than there are bigger airports. There's probably, 50 small airports for every large airport. So by capturing the smaller airports, 1, it's easier, and 2, it gives us more geographical spread as well. So, if you live near an airport, then maybe a good time to buy a sensor, because this software is going to be going into those airports soon.
Very cool. Very cool. Thanks for that. I'm personally curious when it comes to governmental applications, mission critical applications, and the people who would ultimately sign off on using a system such as this. Have you had any conversations about the underlying technology, and how do these entities see the operational factor of these use cases being run on top of blockchain, on top of a DLT such as Hedera?
Exactly. No, this is really, you're asking some really pertinent points there, Tudor, because, one thing that regulators are nervous about is new technology. Whenever there's new technology, they try and slow it down. But the thing is, with what we're doing is the blockchain is being used as an orchestration system. So when I talk about orchestration, what I mean is it's looking at where sensors are. It's looking at what software wants access to those sensors. And then it's enabling all of those connections and providing audit trails so that both parties can be sure that the transactions are clearing correctly. So what it's not doing is pushing all of the data through these blockchain networks, because ultimately then the blockchain networks would then need to go through software assurance and certification, which they don't have. So once the sensor and the software the different sensors and the software is connected, then you've got a peer-to-peer direct connection between the two parties, which is really, really robust, like incredibly robust, to the point where if Hedera goes down, you could switch off the Hedera network, albeit that might be quite difficult because it's a decentralized network. But say the Hedera network were to go down, the two connections will still remain intact. So really, once you've set up the connections, then the Hedera network doesn't actually provide the safety critical function, because you've got a direct connection between the two parties. And that's really how we get around, from a regulatory perspective, how these systems come together. It's like we call it discover, connect, pay, and protect. They're the 4 main functions of the blockchain. So discovering sensors or machines that you want to connecting to them. So actually, they call it hole punching, where you have to hole punch through routers and things like this to actually get to the device that you're trying to talk to. And then payment, so settlement of the transactions. So how do you actually pay for that, and how do you do it in a secure way that I'm only paying if you actually provide me with a service? And then the protection point is basically how you actually secure that payment. So we have like a shared escrow account that all transactions get put into, a little bit like your Visa card. When you pay for something on your Visa card, the amount gets earmarked from your account. So it's in like a clearing stage, and it only actually clears to the recipient once it's proven that the actual service has been received. So that's how we do it. But it's very much an edge network. And that edge networks are quite familiar with, aviators, and the UK regulator are very familiar with edge networks, because ultimately all you're doing is connecting one machine to another machine. And that's really the sweet spot and the beauty of the solution that we've come up with.
I love it. I love to ask you, James, the hard questions, because I know you have a amazing answer for them. So very happy to have you here on board today. I don't want to take up all the airtime for my personal curiosities. I also want to hand it off to Perfectability and Dana and see if they have any burning questions they would like to get an answer for.
Hey, James, always love hearing from you. I love your use case. I've been following for a while. And I got two quick little questions for you. Can you explain in more details how the nanosecond timestamps derived from the atomic clocks enable MLAT, and why is this important for safety critical applications? And then kind of a follow-up question to that, what other safety critical applications, besides drone delivery and air traffic control, could benefit from the sensor? Because I'm thinking like you can pretty much put this thing anywhere. It's a game changer.
100%. Okay, so the timing basically comes from GPS satellites in space. So I don't know if anyone's familiar with the way that GPS satellites work, but they basically have, every second they give you a pulse, which basically allows you to synchronize a clock on board a computer to an atomic time. So basically these things have got, decaying radioactive material in these satellites. And that allows them to basically timestamp or create a pulse from the satellite every second. And what the sensors do is they pick up on this pulse and then synchronize their clock to that pulse, which allows them to estimate, they use FPGA systems, because typical computers and CPUs aren't able to timestamp quick enough. Like, they don't run at a quick enough speed. So they use something called FPGAs. Some of you might be familiar with them, but FPGAs basically are software as hardware, pretty much. So you write your software and then it reconfigures all the transistors in a bit of hardware so that the hardware is actually doing the software, if that makes sense. And what that means is they can run extremely fast. And so when you receive a signal from a plane, say an aircraft is transmitting its signal, basically telling people where it is, when the receiver on the ground receives that, it's then looking at the rising slope of the signal when it was received, and then synchronizing that with the pulse that's coming from the satellites to give you nanosecond timestamps. So you're generally around the 10 to 20 nanoseconds, which is equivalent to when you convert that into distance at the speed of light. In 20 nanoseconds, this light travels around about 20 feet. So I think it's a feet for 1 foot for every nanosecond. So what that enables you to do is to basically pinpoint the position of the aircraft within 20 feet, just using that timing information. And so what that means is when you receive a signal from an aircraft, you can use that timing information from multiple receivers to actually pinpoint the position of the aircraft in space. And that's really, really hard to spoof that, because ultimately, like, you'd have to hack into like multiple receivers simultaneously and compute lots and lots of separate timestamps in a really, really complex fashion to be able to do this. And it's almost inconceivable to happen. So what it does is it adds a layer of security to the data, so that you know that this position from this aircraft is a real aircraft. It's been assured. The position of that aircraft has been assured. And the regulator can now trust that that data is accurate and can be used for air traffic control decisions. And that's the main difference. A lot of these cheaper, more hobbyist networks, they just use something called an SDR, or software defined radio, which is, you can pick them up on Amazon for about 30 or 40 quid. With some, you obviously need some antennas and things to go with them, but they don't have this GNSS chip in them. So they're not synchronized with time. And the timing of this information, isn't, it might be accurate within a few milliseconds or at best, but you're not going to get down to nanoseconds. So, when you're using these kinds of systems, you might only know the position of the aircraft within a few kilometers, which isn't enough to actually assure its position. So that's the main difference, I think, between, this is why we're working with Jet Vision. These guys are the leading sensor manufacturers in the world. They're a German company. They've been around for 15 years. And they actually sell sensors to some of the leading flight tracking networks, the centralized cloud-based flight tracking networks that already exist. So what we're now going to try and do is to actually integrate those existing sensors that are out there into the network. So we've now got multiple, we can go from maybe 100 sensors up to a few thousand sensors very, very quickly now. But that integration, we're talking to the manufacturers and networks at the moment, to go and integrate those sensors. So that's kind of like the next big point. I forgot what your other question was. Can you repeat your second question?
Yeah, and you just blew my mind. Like, I feel like this is like something you would hear like on a science fiction novel, but it's reality. It's insane. It's really cool. Thanks for sharing. And my other question was, what other safety critical applications, besides drone delivery and air traffic control, could benefit from the sensor? Because I feel that you can pretty much put this thing anywhere, and it would be, very valuable for a lot of devices, even like things.
Yeah, 100%. So, we picked a pretty hard use case to be honest, just to start off with. But, if a software solution can be used for a safety critical purpose like air traffic control, then it can certainly be used for everything else. So we kind of see aviation as like the perfect test case in a lot of ways, because it gives people trust that the software actually does what it's meant to do. And once it's been approved by the regulator, which is going through the process at the moment, they're literally paid us to go through this process. So they're going to be holding our hands and taking us through it all. That's basically going to mean that our software is approved to be used in airports around the world, and it's also approved for safety critical applications. So that means, well, what other things could we use it for? Well, an obvious one is robo-taxis. I don't know if you're familiar or you heard some of what's been going on there, but Elon's talking about you renting out your robo-taxi to other people. So if you own a Tesla, you can, with full self-drive, you can actually rent that out to the market, and be earning money while you're sitting at home. That's one clear application, of autonomous vehicles, that we see. We're also seeing, I think humanoid robots, whilst it's a little bit further out, humanoid robots is another clear, example where we see huge growth, because, as I said earlier, nobody thought that we'd be in the stages that we are with AI, where it can, you can almost see a video now on X that looks like the real deal. They can fool anyone nowadays. And to think that we've literally got a system now where we can, input a command by text into ChatGPT, and it will pop out images, videos. It can even write code for you. What we're seeing now is that move towards agents. So an agent is basically just a bit of software that has a goal, is goal orientated. Now you could view a sensor as a goal orientated agent, because ultimately its goal is to give data to anyone that requests it. And it does so autonomously. It doesn't require any human input to provide that data to another machine. So in a way, a sensor could be seen as an agent, but it's a very simple agent. Don't get me wrong. But as we start integrating AI into these agents start becoming quite clever and intelligent and can start doing tasks. So you could train an agent, for example, to, I don't know, code in Java. You could train an agent to code in, I don't know, Python. And if you're a Python or a Java developer, you could be training your own agent. So how do we then start integrating these into software applications? What we see in the future is that, well, over the next few years really, is that, a lot of software is going to really struggle to survive if it's not integrating AI models and AI agents. And I know that sounded a bit, if I said that 5 years ago, people would think that I'm just talking rubbish. But I think hopefully people can start seeing that this technology is real. It's here today. But how do we then start integrating that into different various forms of software? Like you even go into Microsoft Word and, it's finishing your sentences for you now. So this is going to happen more and more and more. We're going to start seeing AI being integrated vertically into these software applications. And that's where value is captured. Value is captured at the customer side. And so by integrating these data sources into these different agents, the different AI models into software applications, they could be seen almost like a sensor in a way. And if you're a software provider, you don't really care what network an agent is on. You don't really care, if it's on the cloud, if it's on a blockchain or anything like that. You just want access to the best agents there are, the best AI models there are, the best data sources there are, and the best machines that there are. And I don't care what network they're on. I just want access to them as a software developer. And so really our value proposition to developers is that's what we're building. We're building a gateway into all of these different resources so you can plug them straight into your software application.
Amazing, James. Thanks for the knowledge. That was incredible. Thank you. And with that, I yield back to Blue.
Thank you very much, Anthony, and thank you so much, Neuron, for presenting all these amazing aspects about your protocol. I think everybody in the audience is a bit amazed and, like Anthony said, mind blown. So the obvious question is, of course, how can the Hedera community get involved with Neuron protocol at this stage?
Awesome. So today, if you want to get involved, the best way is the sensors are now publicly available. So if you go to neuron.world, you can find access to the sensors. You can buy them directly from the manufacturer. So JetVision are now selling them preloaded with Neuron software, ready to go out the box. So you can buy a sensor and contribute in that way. That's the first way. In the next sort of 2 to 3 months, we will be launching the validator network, and certainly the signups for the validator network. And so what the validator network does is, I sort of mentioned it briefly earlier, is all of these machines need to talk and trade with other machines within this network. But what happens if something goes wrong? What happens if one of these actors is nefarious and doesn't actually do what it says it's going to do? So, for example, I don't know, the most easiest example would be somebody switches their sensor off mid-flight while a drone is flying. Now, that's not a helpful thing to do. So what happens in that scenario? Well, firstly, they've breached their service level agreement with the drone operator. So the drone operator has paid for a service they're no longer receiving. So what the validator network does is goes, okay, have you actually complied with the service level agreement? If not, okay, we'll refund the money back to the customer. The customer then provides a bad review for that sensor. So if you're providing a sensor service and you unplug it when you're not meant to, then ultimately you go and get you go and get you have to refund the customer and you get a bad review. That's pretty much normal. So that validator network, what you'll be able to do is sign up. You'll on TGE, you'll earn tokens. So you'll just have to connect your wallet, be able to sign up to the validator network. Once the validator network software is launched, which will be the end of Q2, so around about June of this year, you will then be able to stake tokens to be able to earn rewards. So every single time a transaction is processed through this network, you'll earn a profit share of all of those fees that are collected. And so that's really going to be a really good way to generate passive income for people. You'll basically be benefiting by securing this machine economy. So that's the second way. Otherwise, please visit our website, sign up to our newsletter, and follow us on Twitter. And I think that's probably it.
Thanks a lot, James. Really appreciate you coming here today on a Friday evening and sharing the latest with Neuron. We didn't even have time to dive deeper into your latest award that you got over in Dubai, but I'm sure we're gonna have the time to digest everything that's happening there in maybe an upcoming spaces.